Welcome back, welcome back, welcome back. I'm Lisa Blackburn, and this is my YouTube channel where I talk about anything I want to, science and math. And today we're in physical science class, learning about the nature of science. See, that was a little weird, wasn't it? But hey, I'm thinking one day I'll get merch. You know, maybe. The reason why I started with the welcome back is I was having to, it was during COVID, and I was having to do this by myself, and I was using a better camera. So my earlier videos have a really good camera, but I had to start the video and then walk around, and it was real boring to have dead air, just clump, 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 clump. So I needed something to say while I was getting in front of the board so I could teach. So that's where we start with the welcome back. Welcome to physical science. And I told you that my students that I tutored used to call me Miss Lisa. Now you guys call me Miss Blackburn, but they called me Miss Lisa. Okay, I gotta write on this. I forgot about that. How do I do that? I'll save it. Oh yeah, this is making real good TV here. He's back. That's not it. Now I figured out a better way to do this. It was this. Hold on a second. Oh, I gotta do it over here. Maybe Miss Bird can entertain the video while we're here. You could introduce yourself to the kids who are at home. She's like, no, you're not getting me into this. This is my deal, not theirs. Let's see, desktop, physical science, Word. I gotta unit 1, notes. Now are you going to let me write? Yes. Aha, I found it. Okay. Now I should be able to write on it. Let's see. Yay. Okay. And you would think I would edit that out? Nah. Once the camera's rolling, I go. Okay. So what we're going to be talking about is science. Let me find what I did with mine. Whoop. Once again, extreme close-up. Okay. So does anybody know what the word science means? Anybody know? It's knowledge. The word science means knowledge in Latin. So fill in that blank. It's knowledge. And so one of the first things about physical science is even what is physical science? People sign up for this class and they don't know. So I like to tell you what it is. There are 3 categories of science. The first one is life science. So sometimes it's called natural science. Life science is biology, forensics, zoology, anatomy. Those are your life sciences. So people have come in here before and said, do we get to dissect? No, we do not. The next one deals with the earth and space, and that's called earth science. Earth science. The last one deals with matter and energy. It's chemistry and physics, and it's called physical science. So that's what you're going to learn is chemistry and physics. And how we're going to do it is we're going to spend the first half of the semester on chemistry and the last half on physics. And you'll probably like the physics better than the chemistry. It's a little more interesting, okay? Of course, I'm a chemist. I love chemistry. But for students your age, you get to like play with cars and shoot Nerf guns and things like that in the physics part. And with the chemistry part, we're more mixing chemicals. So it's a little more varied once you get to the physical science. Now, what is technology? It's the application. The application of science to help people. So like if you make a robot, you would be doing technology if that robot is going to help people. Okay, so in every science class, you always start with the scientific method. So what do you do first? Y'all have learned this from elementary school. This is review. Help me out here. What do you do first in the scientific method? You state the... Y'all didn't pay attention in 4th grade. You state the problem. Remember that? You've heard this before. I know you have, because you made it out of 4th grade. Then you gather what? You gather information, or we could say, I wrote too big there. My thing's off. I write here and it goes down there. I'm going to write over here. Gather, I'm going to write information. I'm going to put info. gather some info. Okay, then what do you form? It starts with an H. A hypothesis. See, y'all do know this. It's going down. I need you to see if I can calibrate this board. It is not writing good. Form a hypothesis, and then you test the hypothesis. So hypothesis goes for both 3 and 4. Hypothesis, hypothesis. I'm sorry about how bad this is. I will try to work on the board some. Okay, and then what do? You get that data, and then you analyze the data that you got. So we're going to get data in this class. Oh, look how low it's writing. You analyze the data, and then finally you draw a conclusion. Okay, that's weird. Okay, now, do real scientists, like my son Nathan, who's working at Tech, does he every day go, number 1, state the problem? Do you think he does that? No. Real scientists don't follow this, but they do it in a way. They just don't do step 1, step 2, but they do follow a organized path of inquiry. They do write all their data down, and in fact, it's illegal for him to take his data out of the lab where he works, because he's working on something that will one day be very valuable. If it works, it's a cure for a disease that they think they're about to cure. See, that's physics out in the hall having fun. That's all right. So when we get to physics, we'll get to go to the hall and have some fun. All right, so he always has to write down everything he does, and they always have to keep up with it. My daughter-in-law is a chemist also, and she has to write everything down too. So real scientists don't, see if I can write it here. I'm writing on top of the other one. We'll write it over here, don't. Just make sure that blank is don't. Don't follow this exactly, but they do conduct experiments, make observation, and record data. And just, so we're going to put that they write. You have to write everything down, otherwise you're just having fun. Otherwise you're just messing around, is what the Mythbusters used to say, if you don't write it down. Now, variables. In algebra class, what is a variable? It's what you don't know, right? Like X or Y. And that X can be different what it equals, right? X can be equal to 1, or X can be equal to 1,000,000. X changes what it can be. Everybody follow that idea? So variables can have more than one value. It's actually writing more where I want it to now. And good experiments only change one variable at a time. And I am the worst about this when I get sick. Okay, so when I get sick, I want something to make me better. But I don't just change one thing, I'll change everything at once. I'll take this pill, I'll eat this thing, I'll sleep, I want to change everything. And then I don't know if it makes me well or not. So like somebody says, oh, you need vitamin D. I'm like, great, give me vitamin D. Oh, you need zinc. Oh yeah, give me some zinc. I just will change everything it was, and then I never know if it really worked or not. So the unchanged variable in an experiment is called the constant. And a standard where you compare it to your result is called a control. You have learned every bit of this before, haven't you? Not one bit of this was shocking, was it? Good, good, good. All right, so let's scroll on down to page 2. Okay, so now this might be a little bit new. It's dependent and independent variable. So the dependent variable, so this, look how off that is. Nope, still off, still off, still off. Got it. Whoop, it went away. The dependent variable, that's what goes right there on that blank. The dependent variable changes depending on the other variable. Example, growth. If you're growing we had some little pots growing things. And it's graphed on the y-axis. The independent variable, I'm going to write here. Nope, I'm going to write here. Oh, independent The independent variable, that's what goes on this blank, does not change depending on the other variable, like time, and it's graphed on the x-axis. So this is just a little thing that I didn't learn when I was in high school. I must have been sick that day, gone to the doctor or something, but it was one of those things later, like everybody knew but me, and I'm like, how do y'all know this? And it's when you make a graph, how you know which one goes on the up and which one goes on the other out. The one that goes on the out is the thing that you're not manipulating. So like, you can't change time, can you? There used to be a song about it. You can change me, but I can't change time. It was an old song in the 60s, before my time and yours. But you can't change time. Time is time. Can't go back, can't go forward, time is time. So the thing that you are not changing goes on the bottom. The thing you change, the things that you're going to have a difference about goes up. That's what I want you to know. Does that make sense to everybody? Okay. So real scientists make careful observations and they write them down. You write it down, okay? Now, we've learned two kinds. When I taught you on Tuesday observations, we learned about two kinds. The kind you use your five senses and the kind you use something to measure with. Which one was direct observation, five senses or a tool? Y'all remember? Five senses. And indirect is a tool. So let's fill that into these blanks. Direct, you use your five senses. Indirect is made using scientific measurements. Now, observations can lead to inferences. Who remembers from our earlier this week what an inference is? What is it? An opinion. A conclusion is something you gather from the information. So, observations can lead to opinion. It is an opinion. I'm going to use her word. I like that one. Or a guess. It could be a guess about what's going on. An opinion or a guess based on observations. Now, what is bias? Bias is if you have a biased experiment, is that a good one? No. What have you done if it's biased? You let your opinion cloud your judgment. You let your opinion change the facts. So like, say you think eating M&Ms cause cancer. So you do an experiment, you give a bunch of people M&Ms, you test them for cancer, they don't have it, and you go, yes, M&Ms will prevent cancer. Are you right? No, because you had a bias. You wanted M&Ms to prevent cancer, and they don't. Okay? I'm not saying they cause cancer, but I don't think anybody would say that M&Ms prevent cancer. So what is bias? It's your expectations. Your expectations changing the results. Now, what is a scientific model? That's our next one. So, a scientific model are ways to represent ideas There are ways to represent ideas, events, and objects. Can you tell me an example of a model in science, a way to represent something? Any ideas? What's a model in science, a scientific model? I'll tell you one of my favorites is a globe. A globe is not the earth, but it represents the earth. And we can look at it and see where countries are and stuff, right? So I think a globe is a good one. Sometimes it's just words. Sometimes, like we were going to learn later about the atomic theory of matter. It's words that explain how things are made out of atoms. It's not like a little, you can have a model kit and have a model of an atom, but that's not what it is. It's just words. It's a way to represent ideas. Okay, theories and laws. We're almost through with this. We're doing good. And it's fast, right? But y'all hanging in there? Okay. And also, like, if I go too fast for you and you miss a blank, Miss Bird is one of the things she's going to do is she will always have a copy of the notes, and you can go to her and say, I missed this blank, and she'll help you out with that too. So she's one of the things that because we have so many people in here and we go so fast, and why is there's two teachers, is because two of us can help you. And that's one of the things you can certainly go to her for, because she has all the notes too. Okay? All right, so theories and laws. What's the difference in a theory and a law? Okay? Now, the problem with this is there is a common speech theory that is not the same as a science theory. And so, like, I used to have a theory that was a common speech theory, and my theory is that nobody likes fruitcake. Most fruitcakes are full of alcohol, so they keep forever. And my idea was nobody likes it. They get it for Christmas, they keep it a year, and they just give it to somebody else. But then I had a student who said that's not true, that if you had my grandmama's fruitcake, you would like it too, because I like fruitcake. And I was like, great, bring me some. She never did, so I don't really know if there's any good fruitcake out there, but she said there was. But so is my theory scientific, that nobody in the whole world likes fruitcake? No. Okay, so, but it's common speech, right? You hear, I have a theory about that, and it might be whatever crazy thing that somebody like me has thought of, right? But that is not the use of theory in science. So put that out of your mind and learn instead what a theory and science are. In science, a theory is testable. Can I test to see if everybody in the world hates the fruitcake? No. They don't even know how many people are in the world. So we certainly can't know if they like fruitcake or not. But so the first thing is a theory is testable, okay? It's also based on many observations or experiments. The board is doing a little bit better, writing where I want it to. And they are thought to be true. If you have a scientific theory, it's not just a crazy idea like my fruitcake. It's not a hypothesis. It's thought to be true because there have been hundreds and hundreds of experiments showing it's true. And then an example is the atomic theory of matter. Okay, so that theory is that everything is made out of atoms. Is that true? Is everything made out of atoms? Yes. Do we have lots of experiments showing that is true? Yes. Ever since the mid-1700s, we have had millions of experiments by this point that show that things are made out of atoms. Do we know everything about the atoms at this point? No. Always learning new things. So it's not called the atomic fact of matter. It's the atomic theory of matter because it changes. When Dalton thought of it, all they knew about was atoms. But now we know about protons and neutrons and electrons and subatomic particles like mesons and quarks and gluons. And we know a whole lot. But do we know it all? Nope. There's more to learn. So that's the atomic theory of matter. Okay, everybody got that one? So now what about a law? Did you ever see the Schoolhouse Rock, I'm Just a Bill? And one day I'm going to be a law. Oh, I hope and I pray that I will. Y'all know what I'm talking about? So that's not the kind of law this is. Theories can never be laws. They don't grow up to be a law. A law is something different, okay? So laws are a statement about nature that seems to be true. You're not going to let me write? Nope. Oh, now it's going to... All right, we'll take that. It seems to be true throughout the universe. It's so true that it's represented by math. So it has a formula or a constant. So an example is gravity. It's not the theory of gravity, it's the law of gravity. And gravity is so true, there is a constant with it. The acceleration due to gravity, if you're falling, is 9.8 meters per second squared. It has a number and it has a formula. If you take physics, you'll learn the gravity formula. I'm not going to tell it to you, it's too complicated. Laws are so true, they're math. Okay. Okay, you got that? They're true throughout the universe, we believe. Not that we've been everywhere. Now, there's two things that confuse kids where we use these words common even though it's science. Do you have a question about that? About theories and laws, or do you just need to ask Miss Bird a question? Okay, so what are the two places where we have theories in science that are not scientific theories, but it's common speech theory? And the reason, and because they're not real theories, they're common speech theories, they're controversial. What are the controversial theories in science? There's two of them. You learned them in biology class, one of them. Some people felt a little uncomfortable about it. What? Say it loud, I didn't hear you. All cells are made from pre-existing cells. You're on the right track. So according to biology, how did life begin? Was it always like this?
You talking about the Darwin's theory?
Yes, I'm talking about the Darwin's theory. Okay, so let's talk about it. It's called the theory of evolution and Big Bang. Okay? Are those scientific theories? Can we do lots of testable experiments to see if that happened in the past? Can we do an experiment to prove that true? No. Until we get our time machine and go back, even if we did an experiment now, it would not prove the past. Do you see that? And so this is common speech. A scientific theory has thousands of experiments that support it. Evolution and Big Bang are scientific ideas about historical facts. They are not testable. They're not provable because we don't have a time machine. We can look at some indirect evidence and draw those conclusions, but it is common speech. It is not scientific. Does that make sense? Do y'all know what Big Bang is? So the Big Bang theory is that all the matter in the universe was the size of a softball, and it exploded, and out of it we got everything. Do you see why that might be a little bit controversial? It'd be like there being an explosion in a gold factory and Rolex watches come flying out. A little hard to swallow, right? Especially if you can't do a testable experiment on it. So that's where the controversy comes in. And you're much more complicated than a Rolex watch. You understand that. We understand everything about a Rolex watch. We don't understand a lot about you. Medicine is still working. And that we just discovered a whole new organ system in our body a couple of years ago. A whole system that we didn't realize was there. That's kind of crazy, isn't it? So there's a lot about you we don't even know. Certainly not about the mind. And then evolution was that all matter was unorganized, a primordial muck, and then the atoms organized themselves into biomolecules, and the biomolecules organized themselves into cells, and the cells started reproducing and got more and more complex, and now we got you. Do you understand why that's a little bit controversial? And it goes to what she said. She said cells produce cells, but what produced the cells? Do you see that? So that's where the kids get confused, is we use the word theory of evolution, but really it's not a scientific theory, it is a scientific idea. A theory in science is true. You are made out of atoms, and we have tons of proof, and we can do lots of experiments, and it's about now. It's not about history. Okay? Everybody got that? Okay. Just wanted to... I know where y'all mess up, and so because I've done this for decades, we won't talk about how many. So I try to cut it off before we get there. All right. So if I ask you, give me an example of a scientific theory. Do not write evolution. Write atomic theory of matter. That'll be your one. Okay. Okay. So changing between measurements, we're going to talk about measurement systems very quickly. Sometimes we have to change between measurements, and how we do that is with a conversion factor. And conversion factors always equal 1. Because if you multiply anything by 1, what is its value in math? If you multiply something by 1, what do you get? The same number. So if we multiply something that equals 1, then we will get a number that is similar, that is equal, just different units. So I'm going to show you this one. How many seconds are there to our break? And so our break I'm counting is MLK Day, one of my favorite holidays. So how many seconds is it till MLK Day? Well, it's 11 days. So I can change those days to second using this measurement, this way of doing it. I start with my 11 days. And I put it in some train tracks. I like train tracks better than parentheses because kids will sometimes make their parentheses messy and turn them into the number 6. See, I told you, I've seen people make mistakes before. And one day is the same thing as how many hours? Y'all know that, right? How many hours are in a day? 24, right? 24 hours is one day. So if I multiplied by 24 hours over one day, that's equal to 1, because 24 hours and 1 day is the same thing. And in math, if you divide anything by itself, it equals 1. If you don't understand what I just did mathematically, that's okay. You can still do your math without understanding it. But some of you like to know why. Why? You're that kid who was always going, why? Why is the sky blue, Mama? If that's you, this is why. Conversion factors are based on the number 1. So, but that still didn't tell me how many seconds, so I'm going to break it down to hours. How many minutes are in an hour? 60. So I'm going to multiply it by 60 minutes in 1 hour. But I'm still not to seconds, so I got to do it one more time. How many seconds are in an hour? 60. 60 seconds is 1 hour. So if I multiply all the numbers on top and divide the ones on bottom, I'll get the answer. So in my calculator, I did 11 times 24 times 60 times 60. I didn't bother with the denominator because they're all ones. And if you divide anything by 1, it's equal to that thing. Do you remember that in math class too? You're not going to have one this hard on the test. I was just showing you the ideas behind it. When I put it in my calculator, it was 9,400 seconds. Maybe a few less now. Or no, that'll be at midnight when we start counting our seconds till break. So in my family, we have a tradition of how we celebrate MLK Day is what we've done some years is we've gone to the King Center in Atlanta. Amazing free field trip if you ever get a chance to go there. Incredible. I say you should do it. And then, but we can't always go there. So instead, when my kids were real little, they thought somehow they made the connection between MLK and milk. So they got the idea that Dr. King must have liked milkshakes. So we go out for milkshakes and we toast Dr. King every milk day, every MLK day. Because holidays are more fun with food, right? And I don't personally know that he liked milkshakes, but how could he not, right? So with his initials being MLK. So that's what we do. So if you see us at Chick-fil-A with our milkshakes, you'll know we're celebrating MLK Day and civil rights. Yes. Do you need Miss Bird again or me? Miss Bird. Okay. All right. So how many centimeters are in 4 feet? Did anybody else go out for milkshakes on Milk Day? I've actually found other families who do this. I don't know how it got started, but somehow my kids clued in on that this was going to be the way to celebrate. Okay, so you know Easter baskets at Easter make it more fun. Okay, how many centimeters in 4 feet? So you start with what you know, 4 feet. And then I don't know the number of centimeters in feet, but I do know it in inches. How many inches are in a foot? 12. Did any of y'all do the curriculum where you go, stop, kaput, 12 inches in a foot? It was a little first grade curriculum. So did you do it, Miss Bird?
No.
Stop, kaput, 12 inches in a foot. Now you can all remember it. Okay, so 1 foot is 12 inches. And you're like, I'm never going to forget that because, you know, I already knew that. We don't need that rhyme. We're not first grade. But now I know that that there are 2.54 centimeters in 1 inch. So to do the math, I'd do 4 times 12 times 2.54. Now, any number like 2.54 on a test, I would give you. You don't have to memorize it. And if I did that on my calculator, the answer is 121.92 centimeters. Now, which leads me to my next point. For this class, I know some of you are new. You have to have a scientific calculator. You have to have a calculator to do your math on. I don't want you doing math in your head. If you miss it, I want it to be because you didn't know how to do the math, not because you messed up your mental math. So it's time to have calculators. That's kind of nice, right? But it needs to be scientific and say EE on it. You're looking for EE. So one of the things we're going to do is we're going to have a little quiz to see if you got a calculator. This one will do. This is a cheap little calculator. I think they're $8. You could probably borrow one from somebody. I've heard some of the math teachers are so nice they'll let you borrow one. So anyway, you need to make sure you're getting a calculator. All right. So the kind of units we use in here are the metric units. So in science, we use measurements that can be read. This is so messy. I might run off all of y'all a copy of this. It's so bad. In science class, we use measurements that can be read all over the world. It's because my board needs calibrating, I think. So my son, Nathan, I've told you he's at Georgia Tech doing chemistry. He will watch videos from all over the world. There'll be Indian people doing chemistry, and they'll be speaking what language they speak in India. There's several, but it could be Punjabi or something like that. He'll watch videos from China where they're speaking Mandarin, but what they're writing down, he understands, because we all use the same periodic table. We all use the same numbers. We all use the same measurements, so he doesn't have to understand their words to understand their science. And he watches these all the time. I'm like, maybe you'll pick up the language one day. And he's like, yeah, probably not going to happen. But it's because that's why we have the little France thing there, is we can all read each other's work all over the world. The system is called Le Système International de Units. I'm sure I said that in perfect French. Or we abbreviate it SI for System International. SI, look how far down that was. So it's called SI, much easier, or the international system. It's also called the metric system. Now, it's not really the metric system, but we call it that because it was called that first before they switched to SI. And so, like, there are some measurements in chemistry that we'll use SI, and sometimes we use metric. Now, I bet y'all already know all about what we're about to learn. What is the unit of length for the metric system? What is this called? How far is this? Not a yard, but a meter. Did you already know that? That in metric, you use the meter for length. What do you use for weight or mass? It's not the pound, it's the, does somebody say it? Kilogram or gram, yes. Now, time is the same. What's the smallest unit of time we usually use? Starts with an S? Second. So time is second. Aren't you glad that time's measured the same way? That'd be hard. Okay, current is a weird one. Electricity, it's amps. Amps. Have you ever heard the amps? Or it's short for amperes, but we'll just learn amp. Temperature in SI is Kelvin. It sounds like the name Kevin, but it's Kelvin with an L. Or in metric, it's Celsius. Fahrenheit is English. Volume, we're going to say liters, and we're not going to worry about that other blank. I would make you learn in chemistry. It's cubic decimeters. I just don't really feel like bothering to tell you that. But I will tell you this. A cubic centimeter is the same thing as a milliliter. You use cubic centimeters in medicine. So in medicine, you might get 100 cc's. In science class, we use milliliters. Okay? Last little bit. Energy is a unit called joules. It sounds like a diamond ring, but it's spelled different. Joule. Pressure has several of them. One of them is atmospheres, and that, which is abbreviated ATM, like an ATM machine, and that's the only one we're going to bother learning. There's also ones called millimeters of mercury or bars. You hear them on the weather sometimes. Okay, so the reason why we use the metric system is it's easier, kinda. It's not really all that easy for like cooking and daily stuff, but it is useful for science, okay? So we can convert between units with this little expression. King Henry's daughter bakes delicious chocolate muffins. King Henry's daughter bakes delicious chocolate muffins. What it stands for is kilo, hecto, deca, basic, deci, centi, milli. Okay? Doesn't really matter so much, just that you know how to use this. So here's the order. King Henry's daughter bakes delicious chocolate muffins. I will give you this on the test. K, H, D, B, D, C, M. But in case you ever need to know it out of this class, King Henry's daughter bakes delicious chocolate muffins. Okay? So we can use this to change one number to another. We can change kilometers to millimeters by doing this. So how you do it is, my son Joshua drew her, and he drew her wrong. The princess I wanted was Princess and the Frog Princess. Okay, I want her to be my princess. She's my favorite Disney princess by far. Love her because we have another character in this, which is the frog. Remember the frog and Princess and the Frog? He jumps, and how many times he jumps, that's how we move the decimal place. Okay, so we start at kilo, and we're going to move to millimeter, and we count how many times our prince jumps from one to the other. You ready? 1, 2, 3, 4, 5, 6. So right here is my decimal point. I'm going to make my frog decimal point jump the same number of jumps and in the same direction. 1, 2, 3, 4, 5, 6. That's how many zeros I add. 1, 2, 3, 4, 5, 6 to get my new number. I'll write it over here again because it's a little hard on that board. Sorry, people on TV, you'll just have to imagine. Okay, so my number is 4,800. My decimal point's right there. We'll make it into a frog. Doesn't he look cute? Okay. King Henry's daughter bakes delicious chocolate muffins. I count my frog hops. 1, 2, 3, 4, 5, 6. I make my frog jump 6 times. 1, 2, 3, 4, 5, 6. Wherever there's a jump, I put a 0. In math class, you learned that as augmenting zeros. Do you remember that? Part of 4th grade, augmenting zeros. So my answer is this. That's the number that's the answer. 4800, 1, 2, 3, 4, 5, 6 millimeters. What do you think? Are you going to be able to do it? Well, I'll let you practice. You'll get better at it. Let's do one more. We're going to go from liters to centiliters. So we're at 6 liters. The basic is liters, meters, grams, seconds. So if we're at liters, we're at basic, and we're going to centiliters. Let's count how many frog hops that is. 1, 2. I need a different color that shows up better. Let's try it again. 1, 2. So my frog's right here. He's going to go 2 hops. 1, 2. The answer is 600 centiliters. So we're like using an abacus. Okay? So let's do another one. We're going to change 679,000 milligrams to decagrams. Notice there's a difference between big D and little d. We're going to big D. I'm going to erase this. Start over with my frog hopping. Okay. I'm going to write it again. King Henry's daughter bakes delicious chocolate muffins. I'm starting at milli, and I'm going to deca. 1, 2, 3, 4 hops that way. My number was, that one's got to go. My number was 679,000. 679,000. My frog is right here. He's got to go 4 times this way. 1, 2, 3, 4. So my answer is 67.9. Okay. We'll practice this and it'll get easier. Last idea that I bet you already know. Which of these is a line graph? The first one, the middle one, or the last one? The middle one. Draw an arrow to it. Which of these is a bar graph? The first one or the last one? The last one. Which of these is a circle graph? The first one. Yay, we made it through our first unit. Not too bad. Nobody cried, nobody got a rash. All right. Like, share, subscribe.